Hello students, in this session we are going to discuss the most important 3-mark question, short answer type 2 questions from the first 4 chapters, electric charges and fields, electric potential and capacitance, current, electricity and moving charges and magnetism. So let's move on to the first question. Look at this, 4-point charges Q, capital Q, small q, capital Q, small q are placed at the corners of a square of side A as shown in the figure. Question A, find the resultant electric force on a charge Q. So on a charge Q, what is the resultant electric force? So you can see there is a charge Q here. On that charge Q, what is the resultant force? See, apart from that, there are, you can see, other 3 more charges are there. So total there will be 3 forces on that charge capital Q. And you know, as per superposition principle, how do we find the net force? It is a vector sum of forces produced by individual charges. So let me name these positions, like this point I am going to take as A, this point I will be taking as B, and this point I will be taking as C. So due to this Q, there will be a force. Let me write that one first. So that force I am going to name it as FA. So we get FA is equal to K, that is 1 by 4 pi epsilon naught, that we can substitute later, K into Q1, Q2, small q, capital Q by A square. Because the side of the square is given as A. And what will be the direction of that force? Here you can see all are positive charges. So the force will be repulsive. That means the force FA will be acting like this. This is the direction of FA. Now due to this one, these are identical charges. This is small q, this is also small q. So due to that one as well, so I am going to name it as FC. K into QQ by what? A square. This is FC. What is its direction? Again, it will be repulsion because they are identical charges, like charges. So this is what? FC. All right. So these two are equal forces. They are acting at what? 90 degree. Let's find the resultant of these two. Remember, there will be one more force due to this Q that we will find. But before that, what will be the resultant? Two identical forces are acting mutually perpendicular means their resultant will be through the middle. That means at 45 degree. And it will be, resultant of these two will be vector FA plus what? Vector FC will be equal to root of FA square plus what? FC square, which is equal to, F and FC are equal, we will be getting root 2 times FA, which is equal to root 2 times what is FA? K into QQ by A square. This is what? The resultant of these two. Resultant of those two means, what will be the direction? The direction will be through the middle. So I can rub these two, and I'm just showing the resultant of those two. It is in this direction. This is the resultant of what? FA and FC. Let me name it as F dash. So there is a force F dash acting in this direction. Is that part clear? Yes. That's the resultant of FA and FC. Now there is one more force due to this charge. For that we should measure this distance. What will be that distance? This is A, this is A. So it will be root of A square plus A square. Isn't it? It will be root 2A. Root 2A. What is the name of the force? FB is equal to K into what? Q into Q. Q square by R square. R is root 2A square and we get what? 2A square. 2A square. And what will be the direction of that force? The direction of that force will be in this way only because it is repulsive. Right. Now what you can see is this F dash and that FB are acting in the same direction. Then how can you find the resultant? So net force acting on that Q will be F dash plus what? FB. It is basically vector sum, but here it is simple because both the vectors are acting in the same direction. So what is F dash? F dash value we already found here. Root 2 times K into QQ by what? A square. And what is FB? It is KQ square by 2A square. If anything is common, we can take it out. Like KQ by A square is common, right? KQ by A square is common in both. So we get root 2 into small q, the first term, plus q by 2. This is the magnitude of the resultant force, and the direction will be this way, acting in this way. You can replace that K by 1 by 4 pi epsilon naught. That's the right method. Understood? So I think first question is clear. Remember students, 3-mark questions. So you need to show all the steps properly and make sure that you are concluding the question. Like they're asking what is the resultant force acting on a charge Q. So this is a resultant force acting on a charge Q. Then potential energy of the system. Look at this, dear students. Potential energy of a system of how many charges? This is a system of 4 charges. So 4 charges means you know that there will be many terms, isn't it? What is potential energy of a system of 2 charges? K 1 by 4 pi epsilon naught into Q1 Q2 by R. That is for 2 charges. 3 charges 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. In the same way, if you are writing, what we can write is it is equal to potential energy U is equal to I'm writing it here 1 by 4 pi epsilon naught, that is K into Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q1 Q4 by R14, there will be many terms, plus Q2 Q3 by R23. You need to think about the possibility of all the pairs. Q2 Q4 by R24 and finally Q3 Q4 by R34. So these many terms are there. Okay, because of the space constraint only I am writing like this. So now we can just name these charges. I am going to take this as Q1. This is what? Q2. This is Q3. And this is what? Q4. Now let's substitute here. Check. K into Q1 Q2. Q1 Q2. Q1 is capital Q. Q2 is small q. So QQ. QQ. By what is the distance between those two? It's A. Plus second term, so first term is okay. Second term is Q1 Q3. Q1 Q3. That is capital Q, capital Q. So we get Q square. By the distance between these two. It is root 2A. Root 2A. So second term is also fine. Then Q1 Q4. Q1 Q4. Again capital Q, small q. So plus capital Q, small q divided by the distance is again A. So third term is also fine. Plus, what is the fourth term? Q2, Q3. Where is Q2? Q2 is here, Q3 is here. So QQ. QQ. By again A. QQ by A. So fourth term is also fine. Plus Q2, Q4. Q2, Q4. Q square. Small q square. By what? Root 2A. Root 2A. So fifth term is also fine. Q2, Q4. And now Q3, Q4. What is Q3? This one is Q3. This is Q4. So again you get what? QQ by A. So this is equal to, now you can see QQ by A, QQ by A, QQ by A, QQ by A. 4 times it is coming. So it is K into 4 QQ by A plus Q square by root 2A plus Q square by what? Root 2A. If you want, you can take A out or you can keep like this, no issue. This is the answer. This is what? The potential energy of the system. So don't be confused. Don't skip this type of questions. You just check if 3 charges, 2 charges, 1 charge, like potential energy formula has an identical format. This is the method. I hope this is clear. So first 3 mark question is over. Let's move on to the second one. Question number 2. 3 point charges Q minus 4Q, 2Q are placed at the vertices of an equilateral triangle ABC of side L as shown in figure. Obtain the expression for the magnitude of the resultant force acting on the charge Q. Find out the amount of work done to separate the charges at infinite distance. Okay, let's do the first question. Obtain the expression for the magnitude of the resultant electric force acting on the charge Q. It is given that this is an equilateral triangle. So all sides are equal. They're asking what is the net force on this charge Q. So it is almost similar to the previous question. We need to find the vector sum. So for that, this is Q and this is minus 4Q. So there are 2 charges, Q and what? Minus 4Q. What is the distance between them? L. So let's find the force between that one first. Let me name it as FB because the charge is at the point B. So FB is equal to K into 4Q into Q. So 4Q square by what? L square. Distance is L. This is the force of due to what? FB. Now the direction, be careful. This is a negative charge and this is a positive charge. So we need to find the net force acting on this charge. So you need to check this charge, will it be attracted by this or repelled? This is negative charge and this is what? Positive charge. So surely it will be attracted. That means the direction of FB is like this. This is FB. All right? Yes. Now, what about FC? FC value, we can find FC is equal to K into, what are the charges? 2q square by what? L square. This is FC. This is FC. Okay, yes. Now, what will be the direction? This is positive, this is also positive, so it will be repulsive. So we get something like this. This is what? FC. Now, we need to find the resultant of these two. How can you find the resultant? You can use vector addition formula. So these two vectors are acting at some angle theta, means you know the formula for the resultant. F is equal to root of FA square plus FB square plus 2FA FB cos theta. This is a formula. What is theta? This angle is theta. You know that this is an equilateral triangle, so surely this angle will be 60. That means this angle will be equal to 120 degree. So here we get cos 120. What is cos 120? It is minus 1 by 2. So 2 got cancelled. Okay. Now if you are comparing these two, you can see this is 4kq square by L square. This is 2kq square by L square. That means surely FB is 2 times FC. Double, right? So that will be helpful for us to calculate the resultant. So we get root of, here one is FB, another is FC. So I'm going to take this as FB and this as FC. So this is FB and this as FC. Okay, I'm just changing it. So FC is 2FC. So we get, FB is 2FC. So we get 2FC whole square plus FC square. This 2 got cancelled, minus FB into FC. So FB is again what? 2FC into what? FC. So we get root of 4FC square plus FC square minus 2FC square. Got it? So 4 minus 2FC square. So total we get 3FC square. Root of 3FC square, which is equal to root 3 times FC. So the final answer will be, therefore, net force F net is equal to, what is the result? Root 3 FC. What is FC? Root 3 into FC is K is 1 by 4 pi epsilon naught into what? 2q square by L square. This is the magnitude of, they are asking only the magnitude, no direction. So magnitude of the resultant forces like this. Hope this is clear for you. Please practice 1 or 2 times if you have any confusion. Look at the next. Find out the amount of work done to separate the charges at infinite distance. There is a system. It's a system of how many charges? 3 charges. 3 charges. If you would like to separate to infinite distance, means you are going to break the system. You are going to break the system completely. So they are asking what is the amount of work done to break the system. See, the energy required or the amount of work required to break a system will be equal to what is the energy of the system. That much of work you have to do, then only you can break that system. So indirectly what they are asking is, what is the energy of the system? The amount of work done to separate the charges, or amount of work done to break the system, or amount of work done to dissolve the system. In all these type of questions, they are asking energy of the system only. So this is a system of how many charges? 3 charges. You know the formula for potential energy of a system of 3 charges. What's it? 1 by 4 pi epsilon naught into Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. Substitute, we get 1 by 4 pi epsilon naught into Q1 Q2. You can take this as Q1. Let's take this as Q1, this as Q2, and this as Q3. So tell me students, what is first term? Q1 Q2. Q1 Q2 means minus 4q into q. So we get minus 4q square by L first term plus q1 q3 minus 4q into 2q minus 8q square by L, distance is same, and then q2 q3 q into 2q, so plus 2q square by L. So we can add them 1 by 4 pi epsilon naught into, what will be the result? Minus 4q square plus minus 8q square is minus 12q square plus 2 minus 10q square by L. That's it. This is the answer. This is the energy required to separate the charges to infinite distance. So energy required to separate the charges to infinite distance is nothing but the energy of the system. Got it? Yes. I think this is also clear for you. Let's move on to the third question. Define the term conductivity of a metallic wire. Write its SI unit. Using the concept of free electrons in a conductor, derive the expression for the conductivity of a wire in terms of number density and relaxation time, hence obtain the relation between current density and the applied electric field. Direct question. Please study is using your books. Derivation only. Important derivation. Do you remember the resistivity derivation starting from the concept of drift velocity, right? Conductivity is what? Reciprocal of resistivity. We got an expression for resistivity like m by n is square into tau. Then a conductivity sigma is equal to the reciprocal of this, that is n is square tau by what? M. Then current density. Yesterday in 2-mark question section, I think we explained how do we get the relation between electric field and this conductivity. So please go through that. Important question for 3 marks. Okay. Question number 4. Using Kirchhoff's rules, calculate the current through 40 ohm and 20 ohm resistance in the following circuit. And there is, actually this is an OR question. Derive an expression for the torque acting on a current carrying loop placed in a uniform magnetic field. Direct question, derivation. So please study torque. What was the formula? I'm just writing that one first. Here the answer for this one is tau is equal to NIAB sin theta. Explain the significance of radial magnetic field when current carrying coil is kept in it. So this is a question from moving coil galvanometer. Why are we using radial magnetic field in that? The answer is very simple. If you are using radial magnetic field, in this formula there is theta, no? Theta is the angle between what? Area vector and magnetic field. If you are using radial magnetic field, that theta value will be always 90. If theta is 90, the torque will be maximum. So what is the significance of radial magnetic field means? The answer is we will get maximum torque always. So that part is clear, I think. Now let's do this one. Calculate the current through 40 ohm and 20 ohm resistors. So we need to find current through this and current through this. So do one thing. Let me mark the current through this one as I1, and current through this as what? I2. So I1 current is coming here. If I1 current is coming and reaching a junction, I2 is going this way, means surely the other current should be what? I1 minus I2. I1 minus I2 is flowing through this. Okay, so we can use Kirchhoff's loop rule. So let me start with the loop name. Okay, this I'll be writing here. A, B, C, D, A. This is the loop I'm going to take first. A, B, C, D, A. If I'm going to start from here, I can see minus 80 plus 20 I1, right? Plus 20 I1 plus 40 I2 plus 40 I2 is equal to 0. Or this I can write 20 I1 plus 40 I2 is equal to 80. I can divide by 20, so I get a very simple equation. I1 plus 2 I2 is equal to 4. Take it as equation number 1. Equation number 1. I think that's clear. Now we need to take one more loop. Any loop you can take. Either you can take this one or you can take this one. So I'm taking the bigger one. My loop name is A, B, F, E, A. This is a loop I'm going to take this clockwise direction. I'm again starting from here. Again I can see minus 80 plus 20 I1. Here resistance is 10, current is I1 minus I2. So plus I1 minus I2 into what? 10 minus 40 because EMF is minus is here, so minus 40 is equal to 0. So I can expand it, I get 20 I1 plus what? This one is 10 I1 minus 10 I2. Minus 80 minus 40 will be minus 120, that I am taking to the other side, it will become plus 120. 20 I1 plus 10 I1 will become 30 I1 minus 10 I2 equal to 120. So if you are dividing it by 10, we get 3 I1 minus I2 equal to 12. This is equation number 2. Remember students, we need to find I1 and I2 value. We got two equations in terms of I1 and I2. We can just solve it. This is I1 and this is 3 I1. So to simplify it, we can multiply the first equation by what? 3. So if you are multiplying it by 3, we get what? So I am multiplying. Before that, let me write equation 2 again here. It is 3 I1. This is equation 2, 3 I1 minus I2 equal to 12. This one, if you are multiplying by 3, we get what? 3 I1. Again, 3 into 2 into I2, 2 I2 into 3 will become 6 I2. So 6 I2 equal to 4 into 3 is again what? 12. Is it clear? So please check, is there any mistake in this type of question? Always you should be careful. Minus 80 plus 20 I1 plus 40 I2 is equal to 0. So 20 I1 plus 40 I2 is equal to 80. Dividing by 20, we get I1 plus 2 I2 is equal to 80 by 20 is 4. That's perfect. Second loop is this one. Again, minus 80 plus 20 I1 plus I1 minus I2 into 10 minus 40 is equal to 0. 20 I1, 10 I1 minus 10 I2. Minus 80 minus 40 is minus 120. We are taking to the other side, it is 120. 20 I1 plus 10 I1 is 30 I1 minus 10 I2 is equal to 120. We are dividing by 10. So 3 I1 minus I2 is equal to 12. Perfect. Okay. Now we can solve it easily. Subtract. So if you are subtracting these two, 3 I1 minus 3 I1 will be 0. Minus I2 minus I2 minus 6 I2. Minus I2 minus 6 I2 is minus 9 I2. 12 minus 0. Which means what? I2 is equal to 0. Current through the 40 ohm resistor is how much? 0. If I2 is 0, we can easily find I1. We can substitute in the other one. So we get 3 I1 minus 0 equal to 12. So I1 is equal to what? 12 by 3, which is equal to what? 4 ampere. So dear students, please note that there is no current flowing through what? This one. What may be the reason for that? Because potential at C and potential at D are equal. That's the reason why there is no current flowing through that. I hope this is clear for you. So what is I1 value? I1 is 4 ampere. 4 ampere means current through 20 ohm resistor is 4 ampere and current through 40 ohm resistor is 0. There is no current flowing through the middle part. This one already explained. So 3 mark question, but this is actually an OR question. Either this one or this one. Okay? Yes. Let's move on to the next question number 5. Two large charged plane sheet of charge densities sigma and minus 2 sigma coulomb per meter square are arranged vertically with a separation of d between them. Deduce the expression for the electric field at points to the left of the first sheet, to the right of the second sheet, and between the plates. So here you just look, what is the question? What is the meaning of the question? There are two sheets. Let it be the first sheet. And there is another sheet, larger sheet. They are kept vertically like this. And what is the charge density of the charge density for the first one is sigma. And this is what? Minus 2 sigma. Minus 2 sigma. So I'm just naming this as A and this as what? B. Remember students, one is a positively charged plate and other is a negatively charged plate. We have an expression for the field due to one sheet. What is that? Electric field due to a sheet is sigma by 2 epsilon naught. This is E. Then what will be EA value? Magnitude only I am asking. Magnitude of EA will be, here what is the charge density? It is sigma. So EA will be, what you can write? Sigma by 2 epsilon naught. And what is EB? Magnitude. leave the sign we can apply later. EB will be, what is the charge density? 2 sigma by 2 epsilon naught. We get what? Sigma by epsilon naught. This is EB. This is EB. Understood? So we got the value of EA and EB separately. Now let's see what we can do here. We need to show the direction. This is a positively charged plate. If the plate is positively charged, the field will be into the sheet or out of the sheet. It will be out of the sheet. So I can mark on left side, EA will be towards left. And over here, it is towards right. And here also, EA will be towards right. And the reason is this is a positively charged plate. What about EB? EB is negative. So it has to be into the sheet. Into the sheet. So EB and what? EB. Done. Okay. Now, let's check first. That means they're asking what's the first question to the left of the sheet. Here, what is the field? There are two fields, EA towards left and EB towards right. So net field will be E equal to vector EA plus what? Vector EB. Vector, but one is towards left and other is towards right. So I'm using the normal sign convention concept. Towards left I'm taking negative and towards right I'm taking as what? Positive. So minus EA plus what? EB. Now I can substitute minus of what is EA? Sigma by 2 epsilon naught. Sigma by 2 epsilon naught. And what is EB? Sigma by epsilon naught. So what I can do? I can take sigma by epsilon naught out. I get minus 1 by 2 plus 1. That is 1 by 2. So what is the answer? Sigma by 2 epsilon naught. This is the resultant field where in the region 1. It's a positive. It's a positive means it will be the resultant field direction will be towards right. That's the meaning of the final result is positive. Now, can you tell me in second region? In second region, you can see EA towards right and EB towards left. So again, E equal to EA towards right means EA is positive plus EB is also towards right. So both are positive in the second region. So it's easy to calculate. So what is EA once again? EA is sigma by 2 epsilon naught plus EB is sigma by epsilon naught. So we get sigma by epsilon naught into what? 1 by 2 plus 1 which is equal to 3 by 2. So 3 by 2 into what? Sigma by epsilon naught. Simple. Where? In region 2. Now what about in region 3? In region 3. In region 3, EA towards right and EB towards left. So resultant field will be EA minus EB because EB is towards left. Again, once again, it is sigma by 2 epsilon naught. Which one? EA minus sigma by epsilon naught. I'm going to take sigma by epsilon naught out. I get 1 by 2 minus 1. So it is minus sigma by 2 epsilon naught. What is the significance of this negative sign? That negative, we already taken the sign idea that towards left is negative and towards right is what? Positive. So here we are getting a negative sign, which means the resultant field on this region is towards left. Got it? Yeah. So this one, there are many possibility of asking this question. Here they gave one as sigma and other is minus 2 sigma. They can give one as sigma and other as plus 2 sigma. They can give one as sigma and other as minus 3 sigma. So whatever charge density they are giving, this is the idea you have to follow. First find the field due to both the plates, or they can ask with 3 sheets also. Find the field due to all the sheets. Check the magnitude and direction. Direction is also very important. If positive means it is out, negative means in. That's the way. Got it? Yes. Question number 6. Draw equipotential surface corresponding to the electric field that uniformly increases in magnitude along this z direction. So if a magnitude of field is increasing, they're asking the direction of field is given as what? Z. Electric field is going along z direction, but it is given that the magnitude of field is what? Uniformly increasing. Magnitude is increasing, direction remains what? The same. So if magnitude increases, we have an important point that closer the equipotential surface, stronger what? The electric field. So if you are drawing equipotential surfaces, here if you are drawing like this, then you need to make it closer and closer. See, equipotential surface will become closer and closer as the field strength increases. That's the idea for the first one. If magnitude of electric field increases, you need to draw equipotential surface closer to that. Okay. If magnitude decreases, you need to draw it away. Next question, two charges minus q and plus q are located at point 0, 0, minus a, 0, 0, plus a. What is the electrostatic potential at the points 0, 0, plus or minus z and x comma y comma 0? Okay, so I think this part is clear. I'm going to rub this because I need space to show the other thing. Okay, let it be the x-axis. This is y-axis, and this is the z-axis. X, y, z. This is y dash, this is x dash, and this is z dash. Okay, where are the two charges located? You can see minus q is at minus 0, 0, minus a. So 0, 0, minus a means x coordinate is 0, y coordinate is 0, z coordinate at minus a, there is a charge of minus q. And the other charge is at plus a, that is plus q. Okay. They are asking potential at points. Potential at points 0, 0, plus or minus z. 0, 0, plus or minus z. So x coordinate is 0, y coordinate is 0, z coordinate is what? Z. Plus z and minus z. Electrostatic potential at points plus z. Though that means along which axis only? Along z axis only. The point z is what? Along z axis. Along z axis means you can clearly see that this is a dipole. So along z axis means it is on the axial line, right? Axial line. On axial line, what is the potential? So I am going to write the answer for the first question. Potential due to a dipole formula is V equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into P cos theta by r square. You know, this is the formula. P cos theta by r square. Okay. So this is equal to 1 by 4 pi epsilon naught into on axial line cos theta is 0, so we get P by r square. So P by r square means if it is along positive z axis, that means plus z means the theta will be 0, minus L B theta will be 180. So first answer will be, here you can put z square. And the other one where minus z comes means we get V equal to what? The minus z means on this side, so theta will be 180 degree. So cos 180 is minus 1, so we get minus 1 by 4 pi epsilon naught into what? P by z square. And here actually this formula is applicable for what? Large values of z. So you can write if z is greater than what? A. Because you know distance of separation we are taking small. Understood? If it is not like that, we need to write r square minus z square, but this is okay, it's fine. Clear or not? It is just like the logic of potential due to a dipole on its axial line. And what is the other thing? At points x comma y comma 0. So x comma y comma 0 means z coordinate is what? 0. Z coordinate is 0 and the points x coordinate is x. So it is in xy plane. This is in xy plane at some distance. So we can, I'm just taking that point is over here from the center. So this is what? X comma y. It is in xy plane. Right? Yes. So that xy plane will be, surely xy plane is perpendicular to which axis? Xy plane will be perpendicular to z axis. So it is like if there is a dipole on z axis or axial line, xy plane will be like this, through the middle. So at any point in xy plane, it will be equidistant from where minus q and plus q. Hope you understand. If this is your z axis and the xy plane will be perpendicular to what? The xy plane will be like this. So if you are taking any point on this in xy plane, that will be equidistant from what? Minus q and plus q, isn't it? That means it is a equipotential plane for that. It is the equatorial plane. So what we get? You know that the potential at a point on the equatorial line of the dipole is always 0. So potential is equal to 0 for that point. Hope you understand the second question, because you please check where are the charges kept. Charges are on z axis. And where is this point? This is x comma y. Z coordinate is 0. Z coordinate is 0 means clearly that point is in which plane? It is in xy plane. So xy plane is perpendicular to what? Z axis. So any point on this xy plane, if you are considering, that will be equidistant from where? The z axis. That means minus q and plus q. So potential will be cancelled out. Potential due to minus q will be equal to the potential due to what? Plus q. Equal and opposite potential, it will become what? 0. Got it? Bit confusing question, but check it carefully, get an idea. Next, question number 7. Two infinitely long straight wires A1 and A2 carrying currents I and 2I flowing in the same direction are kept d distance apart. Where should a third straight wire A3 carrying a current 1.5 I be placed between A1 and A2 so that it experiences no net force due to A1 and A2? Does the net force acting on A3 depend on the current flowing through it? Listen, two infinitely long straight wires A1 and A2. So I'm just taking, this is the first conductor A1 and this is A2. So two infinitely long conductors in the same direction, current are carrying in the same direction. So this current is what? I, and this is what? 2I. And they are kept at a distance of d apart. What they are asking is, where should a third straight wire A3 carrying current 1.5 I be placed between A1 and A2? So between A1 and A2 we need to place another conductor, and they are asking at where should that conductor be placed for that the net force acting on it is 0. Whatever is the current carrying by that, net force 0 means, you know that when a current carrying conductor is kept in a magnetic field, it will experience a force. And we have a formula which is ILB into sine theta. So for the force to be 0, field at that point should be 0. So that is a condition here. Field should be 0. So indirectly they are asking at what point the field will be 0. So if you are taking, this is the point where the field is 0. So let's check the possibility of the field to be 0. Like this one is carrying current in upward direction. So this will produce a magnetic field inward. At this point the field will be into the plane, isn't it? Right hand thumb rule, field is into the plane. And this one is carrying current upward again. But this point is on its right side. So if you are applying thumb rule again, it will be outward. So both the fields, field due to this one and field due to this one, will be oppositely directed in between these two. Is that clear? This is field is inward and over here the field is outward. Now what we need to check, if the magnitudes are also equal, directions are opposite, right? If magnitudes are equal, then the net field will be 0. So if you are assuming field due to the first conductor as B1 and field due to the second conductor as B2, what is the condition for the net field to be 0? B1 is equal to what? B2. If B1 is equal to B2, the net field will be 0 because the directions are opposite. What is B1? Field due to this one. So let me take this distance as R. Then surely the remaining distance will be what? D minus R. So what is B1? You know what is magnitude of magnetic field due to an infinitely long straight wire? We have a formula. It is mu naught I by 2 pi R. So I am taking it as first due to the first one, mu naught I by 2 pi R. Current is I, distance is R. B2 will be mu naught into, the current is given as 2I, 2 pi into, what is the distance? D minus R. Many terms will be cancelled. Mu naught by 2 pi will be cancelled on both sides. I will be cancelled on both sides. We get 1 by R is equal to 2 divided by D minus R. That means D minus R is equal to what? 2R. Total distance is D, mu naught I by 2 pi R. This is mu naught into 2I by D minus R. These are the fields, right? Yes. Okay. So we get D is equal to, correct, D is equal to 3R, R is equal to what? D by, perfect. So at a distance of what? D by 3 from the first conductor, we will get a point where the resultant field is 0. When the resultant field is 0, surely the resultant force will also be what? 0. Now they are asking, does the net force acting on A3, A3 means the third wire, depend on the current flowing through it? What do you think? Did we consider that conductor here? No. What we checked is whether the field is 0 or not. If field is 0, force will be 0, no matter how much current that conductor is carrying. So here the conductor is carrying 1.5 I, it is given 1.5. We did not use that at all. That means whatever the current flowing, the force will be 0. So they're asking, does it depend? The answer is no, it does not. It does not. Whatever the current is flowing through that, the force will be 0. Clear or not? Yes. Question number 8. A spherical conducting shell of inner radius r1 and outer radius r2 has a charge q. A charge q is placed at the center of the shell. Find out the surface charge density on the inner and outer surface of the shell. Is the electric field inside the cavity 0? Independent of the fact whether the shell is spherical or not. Explain. Listen here. So, a spherical conducting shell, so let it be this shell, it has an inner radius and outer radius. So, we need to show it like this. Inner radius is r1 and outer radius is what? r2. Has a charge q. Charge will be on the outer surface. You know that charge is q. A charge q is placed at the center of the shell. So, charge q is placed at the center of the shell. Find out the surface charge density on the inner and outer surface of the shell. Surface charge density. What is mean by surface charge density? Surface charge density is charge by area, charge per unit area. So here at the center you can see there is a charge q. So if q charge is kept over here due to electrostatic induction, minus q charge will be induced on the inner side and plus q will be induced on the outer side. The charge will be redistributed on this. You know that. Hope you remember electrostatic induction concept. So minus q will be induced on the inner side and plus q will be induced on the outer side. That's it. Now what they are asking, find the surface charge density on the inner surface. So I'm just taking on the inner surface, we can take it as sigma 1. What is surface charge density formula? Charge by area. What is the charge on here? Minus q by what? Area of the inner surface. It's this radius is r1, so we get what? 4 pi r1 square. Simple question. This is just that, the mark is for that idea. No much calculation. Okay. Now, on the outer surface, if you are taking it as sigma 2 will be what? Q plus Q. Total charge is Q plus Q by its area. What is it? 4 pi r2 square. 4 pi r2 square. This is sigma 2. That's it. We got the answer for the first one. Is the electric field intensity inside the cavity? Cavity with no charge. So this is another question. Here there is a charge inside the cavity. They are asking if there is no charge inside the cavity, will the field be 0? What do you think? Electrostatic properties of a conductor. Electric field inside the cavity of a conductor is 0 because if you are constructing a Gaussian surface over there, the net charge enclosed by the Gaussian surface will be 0. See, with no charge they are asking, is the electric field inside? I am just taking a conductor and there is a cavity here. So inside this, the field will be, surely the field will be 0 because no charge enclosed. If you are constructing a Gaussian surface inside this, the net charge enclosed will be 0. So E is equal to what? 0. Independent of the fact whether the shell is spherical or not. No matter, like shell is spherical or not, what you need to check, inside a conductor, if there is a cavity, electric field will be what? 0. Electrostatic properties of a conductor. So this is actually 3 mark, but it is very easy. There is no much calculation at all, just the basic idea you can use. Okay. Next, number 9. A 200 microfarad parallel plate capacitor having plate separation of 5 millimeter is charged by 100 volt DC source. It remains connected to the source. Using an insulated handle, the distance between the plates is doubled and a dielectric slab of thickness 5 millimeter and dielectric constant 10 is introduced between the plates. Explain with reason how the capacitance, electric field between the plates and energy density of the capacitor will change. This is actually a bit complicated question. You have to check it carefully, listen carefully, then only you will understand. They can change this question easily. Like here you can see the battery remain connected. If battery is disconnected, the entire answer will be changing. So please focus on the concept clearly. So let's check. What is the initial capacitance? It's a 200 microfarad parallel plate capacitor. So let me show it. There is a parallel plate capacitor. So let it be the parallel plate capacitor. It is given as 200. So I am writing it as Z naught, initial capacitance. It is given as 200 microfarad. Okay. Plate separation is given as what? 5. So this distance is given as 5 millimeter. 5 millimeter. Okay. and it is connected to, this is connected to a 10 volt, 100 volt DC source. Okay, there is a potential of 100 volt, that voltage is there. Okay, the distance between the, now be careful, using an insulated handle, battery remain connected, battery is still there, and using an insulated stand, the distance between the plates is doubled, and dielectric slabs of thickness 5 millimeter and dielectric constant 10 is introduced between the plates. So there are two things they are making, two changes. One is distance is doubled. So let's first check what will be the new capacitance when distance is doubled. That's not the question. Question is distance is doubled and a dielectric is inserted, and after that what will be the new capacitance? That is the question. But let's check what will be the effect when distance is doubled. See, if I'm writing Z naught is equal to epsilon naught A by D, then after inserting what? After inserting that, after doubling the plate separation, the new capacitance, if I'm making it as Z dash, it will be what? Epsilon naught A by what? 2D. D is doubled. The epsilon naught A by D is Z naught, so we get Z naught by 2. Z naught by 2. This will be the effective plate separation is doubled. But that's not the question. After doubling it, what they are doing is a dielectric slab of thickness T is given as 5 millimeter and dielectric constant value is 10 is introduced. We have a direct formula for the new capacitance when a dielectric is inserted. What is that? C is equal to, new capacitance is equal to initial capacitance. Remember students, this is our initial capacitance. Before inserting the dielectric slab, C dash divided by, what is the formula? C is equal to C naught divided by 1 minus T by D into 1 minus 1 by K. This is our direct equation for finding the new capacitance. But here C dash is equal to C naught by 2. C naught by 2 divided by 1 minus T by D. D in the sense new distance after doubling. Initially what was the distance? 5 millimeter. Doubling it will become what? 10. So D value is 10. What is thickness of the slab? Thickness of the slab is 5 millimeter. So here we get 5 by 10 into 1 minus 1 by K is what? 10 again. So we get C naught by 2 divided by 1 minus, this is 1 by 2 into 1 minus 1 by 10. C naught value already we know 200, so C naught by 2 will be 100. So numerator will be 100 microfarad divided by 1 minus, we can take 1 by 2 inside, we get 1 minus 1 by 2 plus what? 1 by 20. So this is equal to 100 divided by 1 minus, we can take 20 as LCM, we get 20 minus 10 plus 1. This will go up, we get 2000 in the numerator divided by 11. 2000 by 11, solving you get approximately it as 181.81 microfarad is the answer for this question. Calculation part you can check. So this is the new capacitance. This is the answer for the first question. What will be the new capacitance? We found a clear explanation, clear expression for what? The new capacitance. That part is clear. Now the next one is, what will happen to the electric field between the plates? That's the second question. Electric field. What is electric field formula? You know that. If this is the capacitor plate, already there is an electric field in between. Electric field in between the plates. That if you are taking it as E naught is equal to, we have a formula, electric field in between the plates is E is equal to V into what? D. Sorry, E is equal to V by D. V is equal to E into D, it is V. So what is V? V value is given as 100 volt divided by, what is the distance? Initially, that means before doing all the changes, the distance is given as 5 millimeters, so which is 5 into 10 power minus 3. So we get 100 by 2. 100 by 2 is 20 into what? 10 power 3. 20 into 10 power 3 is what? Initial electric field. We need to find what? The new electric field, yes or no? But when you are finding the new electric field, there are two changes happening. One is this distance is changed. This is, I'm just naming it as D dash. That D dash is, it is doubled. And what? A dielectric slab is inserted. Dielectric slab is inserted. That dielectric slab has a dielectric constant K and a thickness what? Is it clear? Yes. We need to find what? The new electric field. So let us assume the new electric field over here as E. So our aim is to find E. Then what will be the electric field inside the dielectric? We know that it will be E by K. E by K. Understood? Then we can write the formula for potential. Potential, you know that V is equal to potential V is equal to electric field into distance. But this E will be there for a distance D dash minus T. D dash minus T. And this E will be there. That means electric field inside the dielectric. What is its value? E by K. That is for a distance T. So this is, one second, same formula, V is equal to E into D, but E will be there for a distance D minus T plus the new field. What is it? E by K. That will be existing for only a distance what? T. Got it? Yes. So we can take E out. We get what? D minus T plus what? T by K. This is the formula for the potential, but batteries remain connected, which means the potential is same. There is no change in the potential. So new electric field E is equal to what? V divided by D minus T plus what? T by K. Substitute. V is what? 100 by D. New D. D in the sense D dash only. New distance we need to take. So 10 minus 5 plus 5. These are all, remember these distances are in millimeters, so 5 by 10 millimeter means into 10 power minus 3 will come. That 10 power minus 3 will go up, so we get 100 into 10 power 3 divided by 10 minus 5 is 5 plus 1 by 2, so we get 100 into 10 to the power 3 divided by 2 into 5, 10 plus 1, 11 by 2. So what we get? 2000 into 10 to the power 3 divided by what? 11. So you can see what was our E naught value. E naught is 20 into 10 power 3. That is 2 into 10 power 4, right? So here what, if you are comparing with that, if you are taking one more 0 here, or 20 into 10 power 4, if you are taking, 20 into 10 power 3 is E naught. So there is 20, there is 10 power 3. So remaining term is what? 100 by 11. So what we can write is new electric field is equal to, what is the initial electric field E naught? E naught is 20 into 10 power 3. 20 into 10 power 3 is there. Remaining part is 100 by 11. So it is 100 by 11 of what? E naught. Yes or no? Yes. So this is 100 into 10 power 3 into 2 will, one more thing here, it is not 200 only will come, right? 200 into 10 power 3. So only we will have what? 10 by 11 E naught. This is E value. 10 by 11 E naught. Okay. Yes. Now, this is the answer for that electric field question. Now, energy density. So, energy density is the third question. How can we write? Initial energy density is half epsilon naught E naught square. That is initial electric field. So, final energy density will be half epsilon naught into what is new electric field? 10 by 11 into what? E naught the whole square. So 10 square is 100, 11 square is 21 into what? Half epsilon naught into E naught square. This is in initial energy density. So it is 100 by 121 into U. This is U dash, new energy density. Clear or not? Yes. Question number 10. Calculate the potential difference across 4 ohm resistor in the given electrical circuit using Kirchhoff's rules. One of the repeating question. We need to find the potential difference across what? 4 ohm. So for that we need the current through this. There are 2 cells, so you can assume the current from this one as I1 and current coming from this one as what? I2. Surely it's a junction, so the total current will be what? I1 plus I2. I1 plus I2. Let us take some loops here. So let me start with this loop. What's the loop name? Or we can go this way, everything is fine. Loop A, I'm writing here, A, B, C, D, A, that's a loop. Starting from A, if you're writing, we get first 8 plus 8. Current is coming this way, so minus 2I1, minus 2I1. Here current is I2, so plus I2. minus 6 is equal to 0. So we can solve it. Minus 2I1 plus I2. Minus 2I1 plus I2. 8 minus 6 is 2. 2 will go up, go to the other side, will become minus 2. Take it as equation number 1. So we got the first equation by considering this loop. Now we can take another loop. See, for example, I am taking this loop. The loop name is D, E, F, C, D. I am going this way. So first I can see I1 plus I2 into 10, I mean 4. So 4I1 plus what? 4I2. Then there is a current I2 plus I2 into 1 is I2 itself. Minus 6. Minus 6 is equal to 0, but that 6 I can bring it to the other side. So it will become 6. So I2 plus 4I2 will become 5I2. So you can see 4I1 plus what? 5I2 is equal to 6. Equation number 2. Now we need to solve these two. There is a minus 2I1 here. You can multiply it by 2. So equation 1 into what? 2 will get what? Minus 2I1 into 2 is minus 4I1. Minus 4I1 plus I2 into 2 is 2I2. 2I2 is equal to minus 2 into 2 is minus equation number 3. Okay. Now we can add these two. 4I1 minus 4I1 will become 0. 5I2 plus 2I2 is 7I2 equal to what? 6 plus minus 4 will become 2. So I2 is equal to what? 2 by 7. We got I2 value. I2 is 2 by 7. Now we need to find what? I1. Then only we can find I1 plus I2. And I1 plus I2 into 4 will give you the final answer. So we got I2. Now you can substitute in any of this equation. I am going to substitute in this to find I2. So I get, I1 minus 2I1 plus I2. What is I2? 2 by 7 equal to what? Minus 2. Minus 2. Then 2I1 is equal to what? 2I1 is equal to, you can see 2 by 7 plus what? 2. Minus 2I1 will go to the other side, will become plus, minus 2 will come this side. So you can take 7 as LCM. So we get 7 into 2, 14 plus 2, 16. 16 by 7 is 2I1. So I1 is equal to this, in this divided by 2, we'll get 8 by 7 ampere. Right. So we got I1 as what? 8 by 7 and I2 as 2 by 7. Now what will be I1 plus I2 then? So I is equal to, total current is I1 plus I2. So I1 plus I2 is equal to what is 2 by 7 plus what? 8 by 7. Simple. So 10 by 7. 10 by 7 is what? The current flowing through the 4 ohm resistor. What they're asking what is the potential difference across this. So potential difference is current into resistance. So V is equal to 10 by 7 into this resistance, which is 4. The answer is what? 40 by 7 volt. 40 by 7 volt is the answer. Is it clear? Yeah. So no doubt you can, you may be following different loops, different method, no problem. Check the final answer. You will get the same answer if you're not making any mistake. Okay. Let's go to the next question, question number 11. Show on a plot variation of resistivity of a conductor and a typical semiconductor as a function of temperature. Using the expression for the resistivity in terms of number density and relaxation time between the collisions, explain how resistivity in case of a conductor increases while it decreases in a semiconductor with the rise in temperature. So here actually the second part we can explain only after studying the semiconductor chapter. Okay, so normally for the first term exam, this question is not going to come because there is semiconductor part. But the other first part, graph, all of you know, in a semiconductor, it is when temperature increases, resistivity decreases. So it is inversely proportional. And for normal metallic conductors, you know that it is like this. And for a semiconductor, it is like this. So please go through those graphs. They are important. The graphical question from the current electricity chapter. Okay, that drift velocity, temperature dependence, resistivity derivation, always there are questions from that topic. Okay, next is question number 12. A 100 microfarad parallel plate capacitor having plate separation 4 mm is charged by 200 volt DC. The source is now disconnected. When the distance between the plates is doubled and the dielectric slab of thickness 4 mm and dielectric constant 5 is introduced between the plates, how will its capacitance, the electric field and the energy density of the capacitor get affected? Justify an answer in each case. So this question is similar to the 9th question, only one difference here. The source is disconnected. Now the source is disconnected. When the source is disconnected, what will be the change? Like charge remains the same in it, but potential will be changing. So let's check What is the initial capacitance? 100 microfarad. So C naught is given as 100 microfarad. 100 microfarad. Plate separation, D is equal to what? 4 millimeter. Charged by V is equal to 200 volt TC. 200 volt TC. First question is again what will happen to its capacitance. So we can, initial capacitance is given as C naught. So here also, like in the previous case, there are two changes. One is when distance is doubled. Distance is doubled means capacitance will become half. That means it will become 50 microfarad. And then after inserting dielectric, we have a formula C dash is equal to C divided by 1 minus T by D into what? 1 minus 1 by K. So here C is after it is, the plate separation is doubled. So that is half of this. This is 100, so it will be 50 divided by 1 minus T. What is T? T is 4. Okay, so T is 4, but distance, new distance is double means 4 will become 8. So we get 4 by 8 into 1 minus 1 by dielectric constant is 5. So this is equal to 50 divided by 1 minus 4 by 8, that is 1 by 2 into what? 1 minus 1 by 5. So we get 50 divided by 1 minus 1 by 2 plus 1 by 10. So solving we get 50 divided by, we can take 10 as LCM, so you get 10 minus 5 plus 1. So that is 50 divided by 5 plus 1, 6 by 10. This will go up, so it will become 500 by what? 6. This is the new capacitance, 500 by 6. Okay, around 82 something will come. Okay, fine, you can keep like this, 500 by 6 microfarad. This is a new capacitance. Okay, now what is the second question? The electric field between the plates. Electric field between the plates. Here, the problem is, if you are taking this is the new capacitor, like the plate separation, the new distance of separation is 8 millimeter. This is D value, and dielectric is inserted. What's the value of this one? It is 4 millimeter. 4 millimeter. Okay, so we can use in the previous question also we use a technique, but the difference is here the potential is changed. What is the new potential? New potential is, we got the new capacitance. This is a new capacitance, 500 by 6 microfarad, and charge remains same, because once it is disconnected, which quantity remains same means what? It is a charge. So charge, let us find the charge first. You know that Q is equal to CV. So C naught into V. What is C naught? 100 micro into V is what? 200. So we get how many microcoulomb? 2 into, so 20,000 microcoulomb. This is the charge, or 2 into 10 power 4. Okay, this much of micro, because I did not convert micro I am keeping here. So 20,000 microcoulomb is what? Charge. Then let us find the new potential. New potential, V dash is equal to, V is equal to Q by C. That means Q is 20,000 micro divided by the new capacitance. How much it is? 500 divided by 6. So this 2 I can cancel. So I get 200 by 5 into 6. 200 by 5 is 40. Yes or no? So 40 into 6. 240 volt. So the new potential is 240 volt. So we need to find what? New electric field. So we can directly use the formula. New electric field E is equal to, what is E once again? E is equal to V by D. What is the new potential? We got it as 240. 240 divided by new distance. New distance is 8 millimeters. So 8 into 10 to the power minus 3. So 240 by 8 is 30. So we get 30 into 10 to the power 3 volt. This is what? 3 Newton per coulomb. Newton per coulomb. This is the new electric field. Now what we have to find, the third question. So second question is electric field. The third question is about energy density. Energy density, right? So what is initial electric field we got here? Initial electric field we did not find that, so that we can find first. This is what the new electric field. Initial electric field, if you are taking it as E naught is equal to what? V naught by D. What was initial potential? 200 by initial distance is 4 millimeters. So 4 into 10 power minus 3. So we get 50 into 10 power 3 Newton per Coulomb. This is initial electric field. So what is initial energy density? Initial energy density, if you are finding U1, I am taking it as U1, it is half epsilon naught E naught square. New energy density, if you are taking U2, it will be half epsilon naught into what? Half epsilon naught E square, new final electric field square. So half epsilon naught cancel. So U1 by U2 is equal to, what is E naught? 50 into 10 power 3 the whole square divided by 30 into what? 10 to the power 3 the whole square. So this 10 power 3 will be cancelled. So we get U1 by U2 is equal to 50 square, so which is 2500 divided by 30 square, 900. So what is the relation? U1 by U2 is equal to, or U2 is equal to 9 by 25 times U1. This is how energy density is changing. If initial energy density is U1, the final energy density will become 9 by 25 U1. Understood? Yes. Next. 2-point charge plus Q and minus Q are located at points 3a0, 0, 4a, positively in the xy plane, respectively in the xy plane. A third charge Q is kept at the origin. Find the value of Q in terms of Q and A so that the electrostatic potential energy of the system is 0. So let's check the situation here. Where are the two charges? It is on x-axis, right? One is plus Q is kept at 0, 4a. So if I am going to mark this as the origin, this is 4a. So at 0, 4a means at that point plus Q charge is placed. Plus Q charge is placed. And other charge minus Q is placed at, plus Q is kept at 3a0, right? Yes. Plus Q is kept at 3a0. So this is 3a, 0, x coordinate is 0. So here only we are keeping plus Q. And where is minus Q? Minus Q is at 0, 4a. So it is on the y-axis, right? X coordinate is 0, y coordinate is 4a. So here only we are going to keep what? Minus Q. Minus Q. So this is what? 4a. 4a. Got it? Yes. Now, a third charge Q is kept at the origin. The third charge is kept at the origin. Then what they are asking, find the value of Q in terms of small q and a. We need the value of Q in terms of small letter q and a, so that the electrostatic potential energy of the system is 0. Electrostatic potential energy of the system is 0. It is a system of how many charges? It's a system of 3 charges, isn't it? 1, 2, 3. So let me name this. This is Q1, this is Q2, and this is what? Q3. So we have the formula for electrostatic potential energy of a system. It is 1 by 4 pi epsilon naught into what? Q1, Q2 by R12 plus Q1, Q3 by R13 plus Q2, Q3 by R23. This is the formula for electrostatic potential energy of a system of how many charges? 3 charges. Now it is equal to this constant, let us take K, Q1 into Q2, Q1 into Q2 minus QQ, minus Q into plus Q, divided by, what is the distance between Q1 and Q2? 4a, 4a, plus Q1, Q3 minus Q plus Q. So it will become minus Q square divided by the distance between Q1 and Q3. This distance, this is 4a, this is 3a. It's a right angle triangle, so surely it will be what? 5a. You can use Pythagoras theorem. So that is equal to what? 5a. Q2, Q3. What is Q2 plus Q? So we get what? QQ by which distance? 3a. Okay. Now, find the value of Q so that the potential energy of the system is 0. That means LHS is 0. Okay. So here, if I'm taking A out from all these things, I get K by A into what? Minus QQ by 4. minus q square by 5 plus qq by 3. So this is 0 means this term will become 0. So we get what? Minus qq by 4 minus q square by 5 plus qq by 3 is equal to what? 0. 0. So here we can write qq by 3 minus qq by what? 4 is equal to q square by 5. 1 q you can cancel from all the charges, all the terms. So we get q by 3 minus q by 4. So I am going to take 12 as LCM. So we get 4q minus 3q, which is q. So we get q by 12. 4q minus 3q by 12 is equal to what? Q by 5. All right. Yes. Is there any A? No. A becomes 0. So q is equal to what? 12 q by 5. This is the answer for the question. So the capital Q value should be 12 q by 5. 12 q by 5 for the potential energy of the system to be what? 0. Clear? Yes. So just a simple idea, we are just equating the potential energy formula. Question number 14. Two cells of EMF, E1 and E2, have their internal resistance R1 and R2 respectively. Deduce an expression for the equivalent EMF and internal resistance of their parallel combination when connected across an external resistance R. Assume that the two cells are supporting each other. See, it's like two cells connected in parallel. It's a direct derivation only. You just check it. What was the net EMF? They are asking for the equivalent EMF. Equivalent EMF formula is E equal to E1 R2 plus what? E2 R1 divided by R1 plus R2. This is the equivalent EMF formula. Equivalent resistance is this R and the external resistance. Everything will be in parallel. You can find easily. Please study the derivation. It's an important one. In case the two cells are identical, each of EMF E and internal resistance are 2 ohm. Calculate the voltage across the external resistance. So this is a numerical. Let's check. This is one cell. Internal resistance is what? 2 ohm. And this is also what? 2 ohm. It is connected to across an external resistance 10 ohm. Then what's the question? Voltage across. We need to find what? Terminal potential difference. Terminal potential difference formula, you know that V is equal to what? E minus IR. Okay, but how to find I? I is, if identical cells are connected in parallel, the net EMF will be equal to the EMF of one cell. What is the EMF of one cell? 5. So net EMF, E net is equal to 5 volt. 5 volt. And I is equal to what? E by R plus R. So E is equal to 5 divided by external resistance is 10 plus R is internal resistance, means total internal resistance. Total internal resistance is, it is 2 ohm, means 2 and 2 are in parallel. So the total internal resistance will be, parallel means it will be equal resistance, it will become half. So 2 by 2 means we get 1. So this is I, and they are asking what? Voltage. So we can write V is equal to I into R, that is 5 by 11 into what? 10, which is equal to 50 by 11 volt. This is the answer for the second part. Okay? Yes. Question number 15. Write an expression for the magnetic moment associated with a current carrying circular coil of radius r having n turns. Write an expression. Dear students, derivation is also important, but in this question they are asking only to write an expression. What is magnetic moment formula? M is equal to NIA. This is the equation for the magnetic dipole moment. You know that. Consider the above mentioned coil placed in YZ plane with its center at the origin. Derive an expression for the value of magnetic field at the point x, 0, 0. So this is direct derivation. Like circular coil is placed in which plane? So if I am just showing it like this is x-axis, y-axis, z-axis. So circular coil is kept in YZ plane, means something like this. Derive an expression for field at a distance x. So magnetic field into a circular coil derivation, do you remember the formula? B is equal to mu naught Ni a square by 2 into a square plus r square whole raised to 3 by 2. Applications of Biot-Savart law, magnetic field into a circular coil, all of you should study, but here the difference is radius is r. In this equation, a is our radius, so we should replace a by r, and distance is what? X. X is our distance. So you should replace in this r by what? X. Please study that derivation, important one. Define current sensitivity of a galvanometer, write its expression. Current sensitivity, question from moving coil galvanometer. What is meant by current sensitivity? Deflection produced per unit current, phi by I, right? And what is its equation? NAB by K. NAB by K. A galvanometer has a resistance G, shows a full scale deflection for a current IG. Full scale deflection means it is a range of the galvanometer. How can it be converted to an ammeter to measure a current up to I naught? How can you convert? So we need to connect a shunt resistance, you know that? Shunt resistance means we need to connect a low resistance parallel to it, and what is the formula for it? It is Ig into G divided by I minus Ig. This is the formula for what? Shunt resistance. What is I here? I naught, the range of the given, range of the ammeter that we are going to design. What is the effective resistance of this ammeter? Effective resistance will be R is equal to this galvanometer has a resistance what? G, and this shunt resistance is connected parallel to it. So the effective resistance will be Gs by G plus S, but S is negligible. Anyway, finally, approximately you can write R is approximately equal to what? The shunt resistance only. So please go through the topic, conversion of galvanometer into an ammeter and voltmeter. Important topic, questions will come. These kind of questions will come. Okay, I hope this is also very clear for you. Yes or no? So please check step by step in all the questions. Okay.
Okay, now question number 16. An electric field is uniform and acts along positive x direction in the region of positive x. It is also uniform with the same magnitude but acts in the negative x direction in the region of negative x. The value of field is E is equal to 200 Newton per Coulomb for x greater than 0. E is equal to minus 200 Newton per Coulomb for x less than 0. A right circular cylinder of length 20 cm and radius 5 cm has its center at the origin. Its axis along the x-axis so that the flat face is at x is equal to plus 10 and the other is at x is equal to minus 10. See, a lot of explanations. See, we are not going to solve this because this is a solved question this is an NCERT question. Okay, so we have a solution available there. So this we have done in the class also, the same question. You remember we had, see, the whole explanation was about electric field. Once you know the electric field representation, then the calculation is easy. I'll just run through the solution. I'm not going to solve it actually. See, you are given a region where electric field is represented along x-axis. This is positive x-axis and this is negative x-axis. Look at the question. You are given magnitude of electric field is what? 200 Newton per Coulomb. 200 Newton per Coulomb for x greater than 0, which means for positive x-axis, and negative 200 for x less than 0, that is on negative x-axis, which means both of them have same magnitude 200 Newton per Coulomb, but they are in the opposite direction. So that can be represented as electric field in this direction is along positive x-axis is going to be 200 Newton per Coulomb. Along negative x-axis, electric field is what? Is also 200 Newton per Coulomb, which is in the opposite direction as per the question. Yes. Now, you have to consider a cylinder. We have to find out the flex, right? Total flex and the charge across the cylinder. What is that cylinder all about? That right circular cylinder of length 20 centimeter. Total length is 20 centimeter. It is kept like, see, one of its flat surface is at x is equal to plus 10. The other one is at x is equal to minus 10. Plus 10 to minus 10, the distance is 20 centimeters, right? So we have to keep the cylinder on x-axis in such a way that this is how you have to take. See, this is the origin. So we get this as 10 centimeter on this side. This also 10 centimeter. Total length is 20 centimeters. Okay, and we have face area given. Radius of that face area R is 5 centimeter. This is also given. You are asked to find out what is the total flex across the cylinder, right? Question number 1 was what is the net flux across the cylinder. See, net flux across the cylinder, we can find out area, like, flux is contributed only by the flat surfaces. We know that. That is how we explain this question. Only the flat surfaces. Why? The cylindrical, the curved surface of the cylinder, whenever you consider a small area of the curved surface, that ds is normally upward, right? This is upwards. Look at the angle between ds and electric field. It is 90. We know flux is equal to BA cos theta, right? BA cos theta. Electric flux, so it should be EA cos theta. EA cos theta. See, theta will be 90, right? Cos theta is going to be 0. For any point on the surface, curved surface of the cylinder, no flux contribution. So flux, total flux is going to be only equal to, what is total flux? Phi is equal to phi 1 plus phi 2. What is phi 1? Phi 1 is the flux from the left surface, suppose. Then phi 2 is the flux from the second surface, on the right surface. Only the flat faces contribute flux. We know direction of this area is going to be normal to it. Direction of this area also normal to it, outward, ds. We need theta. Theta is the angle between area vector and electric field. See, what is the angle between area vector and electric field here? For this one, electric field is towards right, area vector also towards right, theta is equal to 0 degree. For this one, electric field is towards left, area vector is also towards left, so theta is equal to 0 degree. For there will be positive flux for both the faces. How will you find out that flux? Phi 1? Phi 1 is going to be equal to, electric field strength is 200 into area of the right circular face is going to be pi into r square into cos 0, right? Cos 0, right? That is phi 1. What about phi 2? Exactly the same, because same electric field, same phase area. So E into pi r square into cos 0. Here also angle is 0, right? You can substitute the value of r, pi and electric field. So we get total flux as phi 1 plus phi 2. That will be your final answer. So we have solved this question before. So this is what you have to do altogether, okay? Then you will get total flux. That was only question number 1. What is question number 2? The second part of the question, net charge present in the cylinder. How will you find out the total charge? We know total flux is equal to Q enclosed by epsilon 0. Therefore, what is Q enclosed? Is equal to total flux into epsilon 0. So whatever be the flux value we get here in this calculation, that should be multiplied by epsilon 0 to get the second part of the question. Okay, fine. So you just try that. We are moving to the question number 17. Okay. So differentiate between the random velocity and drift velocity of electrons in an electrical conductor. Okay, we know whenever we consider an electrical conductor, electrons inside the conductor is, they are in random motion, right? They are moving in all possible directions. But they doesn't contribute any current in the conductor because the number of electrons moving in one direction is equal in the opposite direction, an average. So they doesn't make any flow of charge in a particular direction. So current will be 0. They are moving in all random directions. That is called the random velocity. Velocity of this random motion is called random velocity. Then how can you, what to do to keep them moving in one single direction so that there will be a current flowing through the conductor? For that, we have to connect that conductor across a cell. Then that cell will provide a potential difference. That will produce an electric field inside the conductor. Then all the electrons now are moving in one single direction, right? That constitute a current in the conductor. Yes. So the average velocity of that motion is called drift velocity. The other velocity is called the random velocity. This one is called drift velocity. So that is the difference between the two. Now, you're asked to find the order of magnitudes, like which one is faster. That is the question basically, right? Remember, the drift velocity is actually 10 raised to minus 5 times slower, okay, smaller than the other velocity. So drift velocity is smaller, right? Or drift velocity is slower than the random velocity. Okay, fine. That was the first part of the question. Now, B part, a conductor of uniform cross-sectional area is connected across a DC source of variable voltage. Draw graph showing the variation of drift velocity. Yes, drift velocity versus current density. We know whenever we have to draw a graph, we should get a relation between these two quantities first of all. So what about the drift velocity and current density relation? We have the equation current and drift velocity equation, right? NAE into drift velocity. What is current density? Current density is actually I by A. That is the current density J. So if you take this A to the LHS, RHS is only N E VD, where N is the number density of electrons. We have done these kind of questions before. N is a number density of electrons, which is a constant for a given material. E is charge of electron, another constant. We can say J is directly proportional to what? Drift velocity. J is directly proportional to drift velocity. How will you draw the graph? If you take J along y-axis and drift velocity along x-axis, the graph will be a straight line, linear proportional, straight line. Okay, that was question number B. Hope you got it. Moving on to 18, question number 18. A capacitor of capacitance 1 microfarad is charged by connecting a battery of negligible internal resistance of 10 volt. Calculate the amount of charge supplied by the battery in charging the capacitor fully. See, a fully charged capacitor will have a charge Q is equal to C times the applied voltage, right? Fully charged capacitor. Okay, so what is the capacitance of the capacitor given? 1 microfarad into what was the applied potential? 10 volt. So we have 1 into 10 raised to 6 into 10. That is the charge stored in the capacitor will be in coulomb. So we can say 10 into 10 raised to minus 6 coulomb, which is 10 microcoulomb. Okay, that is the charge stored in the capacitor. Fine, that was easy. Question number 19. To convert a given galvanometer into a voltmeter of range 2 volt, 2V, V and V by 2. Resistances R1, R2 and R3 ohms respectively are required to be connected in series with the galvanometer. Obtain the relationship between R1, R2 and R3. Yes. See, we are going to convert galvanometer into voltmeter. We know we can convert galvanometer into voltmeter by connecting a high resistance in series, right? Yes, that is how we convert it into like voltmeter. Yes, we found out the value of R. What was the value of R? We know current flowing through this will be Ig. So we can say total potential difference you measured will be Ig into G, galvanometer resistance, plus Ig into R, the resistance you connected. How will we find that R? Ig R is equal to, what did we get? V minus Ig into G. So dividing by Ig throughout. Expression for resistance to be connected in series, R is equal to V by Ig minus G, right? This was the expression for resistance to be connected, where V is the range of the voltmeter. So that ranges could be different, like 2V, V and V by 2. So whenever you change this V, if you want to change the range, you have to change the resistance also. To get 2V range, we connected R1 as per the question. To connect V, we connected R2. To get the range V by 2, we connected R3. 3 different cases given. You are asked to find out relation between R1, R2 and R3. See, look at this. R1 can be written as R1. What was the range at that time? 2V. So we can write 2V divided by Ig minus G. Correct? Then what next? This is equation number 1. Okay. Then R2. When I change range into V, it is going to be R2. So R2 is going to be just V by Ig minus G, right? Equation number 2. See, there is no change in G. There is no change in Ig. Only changes in range only. Range changes from 2V to V, V to V by 2 by changing the resistances. Okay. Now, equation number 3. R3 is equal to, at that time range is V by 2. V by 2 Ig minus G equals, that is the equation number 3. Okay. Somehow we have to relate these quantities. That's it. Okay. So what will be, if you take equation number 1 and 2, see, we can say equation number 1, from that what will be G? G is equal to 2V by Ig minus R1, correct? From equation number 2, we get G is equal to V by Ig minus R2 minus R2. Okay, so these two equations, both, let me take them as equation number 4 and 5. Both of them LHS is the same, so I am going to equate the RHS. 2V by Ig minus R1 is equal to V by Ig minus R2. Okay, so if I take R1 to the other side, 2V by Ig minus V by Ig is equal to R1 minus R2, correct? R1 minus R2. So what is 2V minus V by Ig? 2V minus V is going to be V only, so V by Ig. I'll just move on. V by Ig is equal to, what is there we have in the RHS of the equation? 2V, I mean R1 minus R2, okay. R1 minus R2. Equation number, suppose 6 or something. This was 4 and 5, right? So the next one is 6. Now, look at this. We have a V by Ig in this one. I have to just bring R3 also into this equation. That is what I am doing. For that, V by Ig. See, V by Ig from this equation. What is V by Ig? We have V by 2 Ig from equation number 3. I told you we have to bring R3 also into it. So, V by 2 Ig is going to be equal to R3 plus G, right? R3 plus G. Okay, so we need only V by Ig. Look at that. LHS we have V by Ig. This is what I am going to replace. So, what is your V by Ig? Take 2 to the other side. V by Ig is equal to 2R3 plus 2G, correct? 2R3 plus 2G. Then substitute this there. 2R3 plus 2G. 2R3 plus 2G is equal to R1 minus R2. So, take R3 to the other side. R1 minus R2 minus 2R3 is equal to what? 2G. That is a relation connecting R1, R2 and R3. Okay. So, you are asked to find out how can you relate R1, R2 and R3. So, R1 minus R2 minus 2R3 is going to be what? 2G. That is a relation we got. Okay. From the three equations, we somehow connected R1, R2 and R3. Okay. Yes. Moving on to the next. Question number 20. Write the relationship between mobility and drift velocity in a current carrying conductor. Yes. Mobility and drift velocity. See, mobility is going to be mu. Is defined as drift velocity divided by electric field you apply. Correct? This is the relation for mobility, connecting drift velocity and electric field. Okay. B part of the question is two aluminum wires have their length in the ratio 2:3 and radii in the ratio 1:3. These are connected in parallel across a battery of EMF E and of negligible internal resistance. Find the ratio of drift velocities of electrons in the two wires. You are asked to find out drift velocity of two different in two different wires, and they are connected in parallel, right? So this is how are they connected, and it is connected across a cell like this. Details given, we have length, same length. Radius of cross section is given 1:3 and connected in parallel. So both of them will have the same potential difference, right? Same potential difference because they are connected across a cell of voltage V. Actually, it is E. So same potential across both the wires. See, how can you relate potential, drift velocity in terms of potential difference, length of the wire, area of cross section. We have drift velocity equation E divided by m into tau, right? This is one form of drift velocity equation. Another form in terms of potential difference, see, E is replaced by, so E is replaced by V by L, right? Potential difference across the terminals, across the ends of the conductor divided by length of the conductor. That is how we substituted that V, replaces E in terms of V. So then we will get E V tau divided by m into L. Okay, right. So now look at this. VD is equal to E V tau divided by ml. In the series, in the parallel combination, V stands for the potential difference. Both of them will have the same potential difference because they are connected in parallel. This is wire 1, this is wire 2. They have same potential difference. So V remains constant throughout. Okay, mass of electron, M is mass of electron, which will be a constant, so we don't have to worry about it. In both the cases, it will be same. Relaxation time is also what? Same only, because that is the property of the material. Charge of electron is another constant. So only length matters, right? As per this equation. So we can say drift velocity Vd is inversely proportional to length of the conductor. All other terms are constants, right? So then we can say Vd1 divided by drift velocity of 2 is equal to L2 by L1, because it is reciprocal of 1 by L1 divided by 1 by L2, so it is L2 by L1. You are given the ratio of length in the ratio 2:3, so the ratio we need is 3 by 2, because it is L2 by L1. So that is your final answer. Okay, drift velocity in terms of potential difference. Okay, 22. An infinitely long straight wire has a uniform linear charge density lambda. Obtain expression for electric field E at a point lying at a distance x from the wire using Gauss's law. Okay, so that derivation part we know. What is the case? We have a long straight current carrying conductor. Like charged conductor. We have to find out electric field at a point E, and we considered, what did we consider? A cylindrical surface, right? Enclosed by, that wire encloses in it, and we found out what is electric field here. Just revise that derivation, and we got expression for electric field as lambda divided by 2 pi epsilon 0 into R, right? That was the equation, or 2 lambda divided by 4 pi epsilon 0 R. That equation you have to obtain, just revise the derivation. Show graphically the variation of this electric field E as a function of distance x. See, you are given distance from the wire as x instead of R, okay? So E is going to be lambda divided by 2 pi epsilon 0 x will be the equation. If you want to draw E versus x graph, you should know what is the relation between E and x. Lambda is a constant, 2 numerical constant, pi constant, epsilon 0 constant. We can say E is inversely proportional to what? The distance x. So what about the graphical representation? If you take E with respect to x, inversely proportional, right? So this is how the electric field is decreasing. Yes. So this derivation and graphical representation of electric field with respect to distance. So that question was easy. 23. Derive the expression for the force acting between two long parallel current carrying conductors. Hence define 1 ampere. See, one of the repeating 3-mark question I told you, using which we can define 1 ampere current also. Yes. So we had two parallel straight conductors, I1 and I2. See, we are not going for the derivation, just revise the derivation. We get the force acting on one. See, there will be a force acting on this conductor because of the other, which is called F12. F21, force acting on the second conductor because of the first. See here, and that is found to be mu naught I1 I2 divided by 2 pi R into L. F12 also of same magnitude, mu naught I1 I2 by 2 pi R into L. And we found out those forces, F on 1 because of the 2, F on 2 because of the 1 are acting towards each other mutually, like attractive force. So same current in the same direction attracts, we know. Okay, so force on the wire in general is going to be these two forces acting towards each other. So mu naught I1 I2 by 2 pi R into L. That was the equation. Okay, just revise that derivation. This is the final expression we got. Then force per unit length is going to be taking L to the LHS, mu naught I1 I2 by 2 pi R. Using that force, we have to define 1 ampere. How did we define 1 ampere? See, to define 1 ampere, we have to consider the force F is equal to mu naught I1 I2 by 2 pi R into L. So if you have two conductors of length 1 meters each, they are separated by a perpendicular distance of 1 meter. Both of them carry the same current I. Okay, I1 and I2 will be the same. Then in this case, what will be the force acting on the conductor? F is equal to 4 pi into 10 raised to minus 7 into I1 into I2 into 1 meter length, 2 pi into 1 meter distance. You can see 4 pi and 2 pi gets cancelled by 2, right? then all these will be cancelled. We get F is equal to 2 into 10 raised to minus 7 into I1 into I2. So what is 1 ampere? 1 ampere is an equal current flowing through two parallel conductors. What if I1 is equal to 1 ampere and I2 is equal to 1 ampere? What happens? 1 into 1 is going to be 1 only. Force is going to be 2 into 10 raised to minus 7 Newton, right? Which means 1 ampere can be defined, or it is the equal current flowing through two parallel conductors of 1 meter length separated by 1 meter distance if they experience a force of 2 into 10 raised to minus 7 Newton. That is how we defined 1 ampere, right? Yes. Okay, using this equation. Fine. Moving on to the next. Differentiate between electrical resistance and resistivity of a conductor. See, we know what is resistance. Resistance and resistivity. Resistance is going to be the resistance or the friction or the block, the opposition to the flow of electric current offered by a conductor. It depends on length of the conductor, area of the cross section, and nature of the material, temperature. Resistivity is resistance of a conductor of uniform length, unit length and unit cross sectional area. That depends only on nature of the material and temperature. Okay, that are the differences. Two metallic rods each of length L, area cross section A1 and A2 having resistivities ρ1 and ρ2 are connected in parallel across a DC battery. Obtain expression for the effective resistivity of the combination. We have to find out the resistivity combination. So we have to find out 1 by R, right? They are connected in parallel. So 1 by R equivalent is going to be equal to 1 by R1 plus 1 by R2. So what is R1? Rho L by A. So you are given length, same length L, and what about area cross section? A1 and A2. Their resistivities are ρ1 and ρ2. So ρ1 and ρ2 given here. See, L remains the same for all. R2 is equal to ρ2 L by A2. So if you substitute 1 by R equivalent is going to be rho L by what will be the area of cross section. When you connect them in parallel, we can imagine both of them are put side by side. So total area is going to be A1 plus A2, correct? So length remains the same. Area will be doubled. So we can say rho L by A1 plus A2 is equal to 1 by R1 is going to be A1 by ρ1 L plus A2 by ρ2 L, right? That is what we get. So this one is going to be just the reciprocal. Take A1 plus A2 divided by rho, right? Into L, and L remains the same throughout. So we can cancel L from all of them. Yes, so divided by rho is equal to A1 by ρ1 plus A2 by ρ2. So this can be ρ1 ρ2 A1 ρ2 plus A2 ρ1, correct? That is how we can simplify. This will be A1 plus A2 divided by rho. Take the reciprocal and you will get the final answer. Rho is equal to what is the effective equivalent resistivity. So let me take the reciprocal of this. Okay, come here, and rho divided by A1 plus A2 is equal to ρ1 ρ2 divided by ρ2 A1 plus ρ1 A2. So what is rho finally? Rho is equal to A1 plus A2 into ρ1 ρ2 the whole divided by ρ2 A1 plus ρ1 A2. That is your equivalent resistivity in terms of resistivity and area of cross section. That is how we got it. So we started with the resistance combination only, and we substituted resistance as resistivity, length and area of cross section. Length was same in all the cases, whether you have taken one single one or combination in parallel, length remains the same, but area of cross section will be A1 plus A2. That changes we substituted, we got the relation finally. Okay. Question number 25. A uniformly charged plane sheet has charge density sigma, which is equal to 1 by 18 pi into 10 raised to minus 15 coulomb per meter square. Find the electric field at the point A, which is 50 centimeter from the sheet. Okay, you are given a distance 15 centimeter from the sheet and sigma value is given. We know electric field due to a charged sheet is only just sigma by 2 epsilon 0, and this 50 has no relevance in our calculation. Electric field due to a charged sheet is independent of the distance from the sheet, right? Yes. So E is equal to sigma by 2 epsilon 0. You are given sigma, substitute epsilon 0 there, you will get the final answer. So let us just try that. We get E is equal to sigma divided by 2 epsilon 0. What is your sigma value? Sigma value is 1 by 18 pi into 10 raised to minus 15. 1 by 18 pi into 10 raised to minus 15. That is your sigma. The whole divided by 2 into epsilon 0. Okay, we can do one thing here. We know 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9, right? So what could be 1 by epsilon 0? 4 pi into 10 raised 9 into 10 raised to 9, correct? 9 into 10 raised to 9. So that will be easy for calculation then. Look at this. E is equal to, see, 1 by 2 into 18 pi, okay, into 10 raised to minus 15 into epsilon 0. That was this term. Now 1 by epsilon 0 can be this. So we can write 10 raised to minus 15 divided by 36 pi into, what is 1 by 4 pi epsilon 0? 4 pi into 9 into 10 raised to 9. Okay. So that's it. We can cancel 36 and this by 9. 9 gets cancelled. We get just 10 raised to minus 15 into 10 raised to 9. We get 10 raised to minus 6 Newton per Coulomb. That was the electric field strength. Okay. So we just substitute and simplify. That's it. All values were given. But that 50 has no role in the calculation. It is independent of the distance from the charged sheet. Okay, wait. We have a sub question further. Consider the straight line, a line with 3 points P, Q and R. See, P, Q and R. Place it 50 centimeter from the charged sheet on the right side as shown in the figure. At which of these points does the magnitude of electric field due to the sheet remains the same as that at the point A and Y? See, we considered infinitely large thin sheet so that it produce uniform electric field, right? Like this around it. See, here also there will be uniform electric field in this direction. Yes. But look at the size of that sheet. It is 10 centimeter and you are going 50 centimeter away from it. 10 centimeter, you are going 50 centimeter away from it. So if you consider 50 centimeter, this 10 centimeter size is not infinitely long sheet. It is a finite sheet then, right? It's just a finite sheet. So the electric field is going to be just uniform only in this region, right? Only in this region. So when you go to higher distances, just take this as a point charge, right? A point charge source. So we will take the center as the reference point. So at the point Q only you can take the electric field same as that of the point A. When you go to further distance, it is considered to be a point charge. Okay, right. So the answer for this question is point Q. Right? Don't see, actually we supposed to take P, Q and R should be of same electric field because uniform field is coming up. But that is for infinitely long sheet. Field is same everywhere. This is not an infinitely long sheet when you compare 50 centimeter distance. Okay, that is why we restricted that into the center, midpoint of the sheet only. Fine. 26. Consider two conducting wires A and B of the same diameter but made of different materials joined in series across a battery. The number density of electrons A in 1.5 times that in B. Find ratio of drift velocity of electrons in wire A that in wire B. So drift velocity of electron, we are given some hints here, ratio of same diameter. They are of same diameter, which means same radius of cross section, same area of cross section. Okay. The number density ratio is also given 1.5 times than in B. So somehow can you relate drift velocity, number density, area of cross section? We know this equation, right? Since they are connected in series, that means same current also. A hint is given about same current. So drift velocity and current relation equation. What was the equation? I is equal to NAE into drift velocity VD. Okay, so here you're asked to find out drift velocity ratio. So if you go for the first wire, I of A is equal to N of A. E is the charge of electrons. So that is same for both the wires. Area of cross section is also same for both the wires because it is given as same diameter, cross sectional diameter. And V D of A. I B is equal to N of B. E A drift velocity of B. Take the ratio, we get the answer. See, IA by IB is equal to NA divided by NB into E and A gets cancelled because they are same for both the cases. Drift velocity of A, drift velocity of B. You are given this ratio is 1 because series combination, right? When they are connected in series, I1 is equal to I2. So IA is equal to IB, which is equal to 1. Now, NA, you are given number density of electrons in A is 1.5 times that in B. So we can say 1.5 times NB divided by NB, right? Into VD of A divided by VD of B. See, NB gets cancelled. We can take this 1.5 to the LHS. So what is the result now? Finally, we got 1 by 1.5 is equal to drift velocity of A by drift velocity of B, right? Or it is going to be 2 by 3, right? That is a ratio. Good. Fine. Question number 27. Two slabs of dielectric constants 2K and K filled in the space between the plates of parallel plate capacitor of plate area A and plate separation D as shown in the figure. See, we have done a similar question before, right, in the 2-mark sessions. There we are asked to compare or get a relation between K, K1 and K2 by comparing two capacitors. So this is only a half portion of it. You can imagine this capacitor as a combination of CA and CB connected in parallel. So we can say 1 by C equivalent of this combination is equal to, series combination, right? They are connected in series, end-to-end connection. So series combination, 1 by CA plus 1 by CB, right? Total equivalent capacitance will be like this. So how can you write CA? Simply we can write CA here. CA is going to be epsilon 0 A divided by D is the expression for parallel plate capacitor filled with a dielectric constant of 2K. So we have to multiply with 2 and K also. And look at D. Area of the plate is A only, but D is D by 3. So this is D by 3. Got it? So CA is going to be 2 into 3 is going to be 6. K epsilon 0 A divided by D. Okay, can you help me to write the expression for capacitance of CB also? What is CB? CB epsilon 0. So in the same way, epsilon 0 A by D, but it is filled with another dielectric material of K. So K times epsilon 0 A, and look at that, D is 2D by 3. A is the same. So 2D divided by 3. So that 3 comes up, we get 3K epsilon 0 divided by 2D. These are the two equations, like CA and CB. Now you can proceed here. What will you get? 1 by C equivalent is equal to reciprocal of A, CA, D divided by 6K epsilon 0 A, 6K epsilon 0 A, right, plus CB. CB is going to be 2D divided by 3K epsilon 0 A, right? So we can take 6K epsilon 0 A as the LCM, right? So we get D plus 4D, right? 4D, because 2 times should be multiplied. So we get 5D divided by 6K epsilon 0 A, that is 1 by C equivalent. So what is your final answer? So expression for capacitance of this capacitor, C equivalent is the reciprocal, 6 times K epsilon 0 A by 5D, right? That is the final answer. So we have done a similar question before. At that time it was D by 2, D by 2, right? Now it is parted in different ways. Still we have the same procedure and we got the final answer. Okay, 28. Define current density and relaxation time. We know current density, I is going to be, J is going to be current flowing per unit area. It's a vector quantity. Relaxation time is the average time interval between successive collisions of electron with the positive ions during their motion. Derive an expression for resistivity of the conductor in terms of number density and charge carriers in the conductor. In one of the questions, we have already done that. Resistance, right? Expression for resistivity, like in terms of relaxation time, number density. We have already done, so just refer that. Question number 29. 3-point charges Q1, Q2 and Q3 are located at 3 different points given. Calculate the electrostatic potential energy of the system of charges, right? So we can just represent these charges in the coordinate points. So the first one is given at 0, 0 in the xy, which is Q1. So we have a Q1 kept here and Q2 is kept at 0,3 centimeter, which means 3 centimeters on y-axis. This is 3 centimeter. This is your second charge. What is the second charge? Q2 is 10 microcoulomb. Yes. This is Q1. Q1 is actually minus, okay? Minus 15 microcoulomb. And we have one more charge which is kept at 4 centimeter, 3 centimeter. 4, 3 is actually 4 along x-axis, okay? So 4 along x-axis and 3 along y-axis. So this is the third position, like third charge that is given as 16 microcoulomb. Yes. So we can imagine a triangular like arrangement of charges. This is 3 centimeter. Then this is 4 centimeter as per the given point, like 4, 3. Yes, then definitely what will be this distance? This is going to be 5 centimeter. So we have distances given, pair of charges given. What is the total distance? I mean, what is the total potential difference? How many independent pair of charges possible? 3. So if this is Q1, this is Q2 and this is Q3. We can go for K Q1 Q2 by R12 plus K Q2 Q3 divided by R23 plus K Q1 Q3 divided by R13. Okay, so you can substitute the values of Q1, Q2, Q3 and their respective distances. All distances are given, all charges also are given. Just substitute and simplify. Okay, that will give you electrostatic potential energy of the system. Okay, now 30. Question number 30 is about a given circuit. See, which points are in the same potential in the given circuit? Which are the 2 points with the same potential? Sorry. Look at the diagram. A, we are given 2 points like on this branch D and E. We know whenever there is a resistor connected between 2 points A and B, there will be a potential difference between A and B, right? Because current is flowing from A to B, suppose high to low, there is a potential difference. Look at these 2 points D and E, right? Is there any resistance connected in between? No. So D and E are 2 points with the same potential, at the same potential, because there is no resistor connected. Whenever there is a resistor connected, there will be a potential drop across it. Okay, what is the current through arm BG? Okay, what is this current is the question, arm BG, which can be easily calculated. Look at this. This branch has a resistance 10 ohm, right? 10 ohm. What is the resistance in the other branch? R2 plus R3, that is also 10 ohm, right? 10 ohm. So two 10 ohms are connected in parallel. So what is the equivalent? 10 by 2, 5 ohm. R equivalent of this circuit is just 5 ohm. Is that okay? This branch, wait. This branch and this branch is going to be 10 and 10. So it is going to be 5. I didn't see this resistance. That also to be counted, right? So 10 ohm and 10 ohm in parallel, we get 5 plus 1. See, this is in series. These two are in parallel together in series with this one. So we got R equivalent is what? 6 ohm, right? 6 ohm is R equivalent. Then what is the potential given? 6 volt. What could be the current? What is the total current flowing through the circuit? V by R equivalent. What is V? It is 6 volt. What is R equivalent? 6 ohm. So we get current flowing through this is going to be 6 by 6, which is equal to 1 ampere current. 1 ampere current is flowing through this. This is 1 ampere current. This is also 1 ampere current. But at the point B, it splits into two. One going through BG and the other one is going to BC branch, this branch. Since both of them have 10 ohm resistances each, current will be divided into equal halves, right? I by 2 and I by 2. What is the current? Total current is 1 ampere. So 0.5 along this, 0.5 along the other branch. So the question was, what is the current across BG, which is 0.5 ampere? Easily we could solve it. Okay. Right. Find the potential difference across the resistance R3. Potential difference across any given resistance R3. R is going to be V equals to IR. What was the current flowing through this? 0.5 ampere current, right? We know. This is I by 2 is 0.5 only. 0.5 is flowing through 5 ohm resistance. So we get 0.5 into 5, which is 2.5 volt. That is the potential drop. Okay. Yes. So that is how we solved the question. I hope it is clear. Thank you.